So hello everybody, welcome back to MRS math class. Hope you are fine. So today I am going to explain the last method to solve the non-homogeneous linear equations with constant coefficients. Okay, in the previous class I have already discussed about the operator method and undetermined coefficient methods, right? So this is the Latch method, right? So that one the differential equations, that is of the form d square y by dx square plus a1 dy by dx plus a2y equal to f of x, right? So this is a second order differential equation, okay, and this is non-homogeneous, okay. So here how we can get the particular integral, okay. So we know the general solution is the sum of complementary function and particular integral, right? So in the previous class we are calculating complementary function separately and particular integral separately, but here we are going to calculate the particular integral from the complementary function itself, okay. So let us discuss about the theory, okay. This is the general form of the second order non-homogeneous differential equation with constant coefficients, okay. So let us consider the complementary function, okay, for this equation as yc equal to c1 y1 plus c2 y2, okay. So here c1 c2 are constants, right? But here to apply this variation of parameter method, we have to assume that c1 and c2 are functions of x, okay. Then what we can write? Yc equal to c1 of x y1 plus c2 of x y2, right? So this one will be our solution, right? So we can take this as yp, okay, we can take this as yp. So if we will assume this is the solution, then that should satisfy this equation. So what we have to do, we have to take the first derivative, right? That is yp dash, that will be c1 of dash x1, okay, c1 dash y1, okay, plus c2 dash y2, right, plus c1 of x y1 dash plus c2 of x y2 dash, okay. So if we will assume that these terms are same for the for assuming c1 and c2 as constant, then this first term, okay, c1 dash x plus y1 c2 dash x plus y2, that will be equal to 0, correct? So we can write c1 dash x y1 plus c2 dash x y2 is equal to 0, right? We have to assume this one if we will consider c1 c2 as constant, okay. Then if we will apply this one as 0, then what will be our yp dash? That will be only c1 of x y1 dash plus c2 of x y2 dash, okay. Now from here we have to calculate our y double dash, okay. So what it will be? Yp double dash will be c1 dash x, right, y1 double dash, correct, plus y1 dash c1 dash x, correct, plus c2 dash x y2 dash plus c2 of x y2 double dash, right? This is c1 dash y1 double dash, and this is, oh, that should be c1, right, c1 y double dash, then y dash c1 dash, okay. So here so here we can demand that this one c1 dash y1 dash c2 dash y2 dash should be equal to 0. That we cannot demand, right? We cannot demand that c1 dash y1 dash, okay, plus c2 dash y2 dash is equal to 0. Why you cannot demand? Because already you have taken that c1 and c2 are the function of x, so we cannot demand this as 0. Okay, so let us take this as equation number 3. Okay, so this is, we can take, this is 3, this is 4. Okay, so from 3 and 4, if we will apply here, then what we will get? We can apply here. Okay, then what we will get? Y2 double dash, right? So c1 of x y1 double dash plus y1 dash c1 dash x plus c2 dash y2 dash plus c2 of x y2 double dash. Okay, this one, correct? Now plus a1 into y dash, that is dash one, this one, c1 of x y1 dash plus c2 of x y2 dash, correct? This is our yp dash plus a2 into yp. So what is our yp? Yp is this one. Okay, let us take this one as start. So c1 of x y1 plus c2 of x y2. Okay, this is equal to our f of x. Okay, so from here we can see that we have already assumed that y1 and y2 are the solutions for this homogeneous. Okay, we have assumed that y1 and y2 are the solutions of the homogeneous differential equation. Okay, that means y1 and y2 should satisfy this homogeneous differential equation by taking this f of x as 0. That means our d2y1 by dx square plus a1 dy1 by dx plus a2y1 equal to 0. Okay, so here you can see that if you are taking common this c1 of x, okay, then what we will get here? Y1 double dash, okay, y1 double dash, okay, then a1 y1 dash, right, plus a1 y1 dash plus a2 y1, correct, plus c2 of x. If you are taking common, then what we will get? That is y2 double dash, okay, plus a2 y2 dash, okay, sorry, this is a1, right, a1 y2 dash, okay, plus here a2 into y2, right, a2 into y2, okay. So the remaining terms are, what we can write? Y1 dash c1 dash x y1 dash plus c2 dash x y2 dash, okay, is equal to f of x. Okay, so these terms we can take as 0, and also this term we can take as 0, because this y1 and y2 are the solutions for the homogeneous differential equation. So what we can write from here? We can write only c1 dash x y1 dash plus c2 dash x y2 dash is equal to f of x. So this one we can take as equation number 5. Okay, so here in equation 5 and in equation 2 there are two equations and two unknowns, that is c1 dash and c2 dash. Okay, so here what we will do? we will solve this equation 2 and equation 5, okay, so that we will get c1 dash x and c2 dash x, okay. So we can write the two equations, that is c1 dash x y1 dash plus c2 dash x y2 dash is equal to f of x, okay, and another equation is c1 x y1 plus c2 dash x y2 is equal to 0, okay. So let us take so these two equations are there, okay, and two unknowns, that is c1 dash and c2 dash. We will calculate c1 dash c2 dash. After that, to find c1 and c2 we will integrate, okay. After that we can put it in the general equation, so that will be our particular integral, okay. So if we will solve these two equations, what we will get? We will get c1 dash x as minus of y2 into f of x, okay, by y1 y2 y1 dash y2 dash. So what is this? This is Wronskian of y1 and y2, okay. So what we can write? y2 f of x by w of y1 y2. So what is this Wronskian? That will be, that is y1 y2 dash minus y2 y1 dash, okay. So determinant of this is our Wronskian of w1 y1 and y2, okay. Similarly, c2 dash x, it will be y1 into f of x divided by Wronskian of y1 and y2, okay. So this is our c1 dash and c2 dash, okay. So from here, how we will get c1x? By integrating, right? c1 of x, it will be minus of integration, that is y2 f of x by Wronskian of y1 y2, okay, d of x, okay, and c2 of x will be integration of y1 f of x divided by Wronskian of y1 y2, okay, to dx, okay. So this is our c1 and c2, okay. Since we got c1 and c2, so our particular integral will be what we can write? That will be yp equal to c1 of x y1 plus c2 of x y2, correct. So what is our c1? That means this one, integration of y2 f of x by Wronskian of y1 comma y2, correct, dx into y1 plus y1 f of x by Wronskian of y1 comma y2 dx into y2, correct. So this is our yp, okay. So here note we can write, that is this formula, this variation of parameter method we can apply even if this a1 and a2 are two functions of x, okay. And this also, this formula we can extend up to the nth order, okay. Here we have considered up to the second order, but this method can be extended up to the nth order, okay. So our general solution is yc plus yp, okay. So hope this method is clear to you. Now to understand it more clearly, we can take one example and we can solve it, okay. So let us proceed for the example, okay. So this is a common question always coming in the exam, okay. So this one I have considered, okay. So let us solve this one by the method of variation of parameters. Okay, so here first of all we have to calculate the complementary function. Okay, for that what we have to do, that is d square plus 1 is equal to 0. Okay, so our d will be plus minus I. Okay, so yc will be c1 cos x plus c2 sin x. Okay, so from here we have to calculate the particular integral. Okay, so for that yp we have to consider as c1 of x cos x. Okay, c2 of x sin x. Okay, so here y1, so let us write y1 as cos x and y2 as sin x. Correct. So our Wronskian y1 y2, it will be, that is y1 y2 first of all. Okay, that is cos x and sin x. This is y1 dash, that is minus sin x, and this is y2 dash, that is cos x. Okay, so Wronskian will be cos x into cos x, that will be cos square x. Okay, minus, and this minus, so it will be plus sin x into sin x will be sin square x, so that will be equal to 1. So our Wronskian is 1. Okay, so for that what we will do, we will calculate c1 of x. Okay, so that will be integration of minus of y2, right, that means sin x into f of x, right, so that is f of x is our cosec x, correct, into dx, right, divided by this one 1. Okay, so what we can write, sin x into cosec x is 1 by sin x, so it will cancel, so we can write only minus x. Okay, that is our c1 of x. So what will be our c2 of x, that is y1, so what is y1 here, cos x into cosec x, correct, that will be our f of x. Okay, cosec x into dx, right, divided by 1, so there is no problem. Okay, so this will be cos x into this will be our 1 by sin x, so cot x integration is log of sin x sin x, right, plus c. Okay, that one no need to write, only we want to calculate c1 c2, so this is log sin x. Okay, so what will be our final yp, that is c1 of x, right, so what is c1 of x, that is minus x into y1, right, minus x into cos x. Okay, and c2 of x sin x, so that is log of sin x into sin x. Okay, so this is our yp. Okay, and this is our yc. Okay, so general solution is yp plus yc. Okay, so hope you understood this method. Okay, if we remember the formula, that is c1 and c2, then immediately we can do that. Okay, so one simple and important problem I have considered. Okay, and I explained using the method of variation of parameters. Okay, so if you understood this one, then you can from your side you can try more and more problems. Okay, if you face any doubt, please write it in the comment box. Okay students, thank you for watching.